All right, we're going to look at lesson 4.2. This is writing the equation of a line. And so first, you got the option of doing standard form or slope-intercept. So let's remember standard form. That's a times x plus b times y equals c, where a has to be positive and all numbers a, b, and c are whole numbers. Then slope-intercept form that we've used most often will be y equals mx plus b, where b is my y-intercept and m is my slope. So looking at my graphs here, if we're doing slope-intercept form, we know it's going to be y equals. And so I have a point here, and let's look first. This is going down to the right. So if we're going down that way, that's going to be a negative slope. If we're going up that way, that's going to be positive. So if you remember the slope guy, kind of helps us out to remember that. So just as we're figuring it out, my slope first, I'm going down 2 and to the right 1, 2, 3, 4, 5. So that gives me a slope of negative 2 over 5. And so y equals slope times x plus b, which is our y-intercept, and that is 1, 2, 3, 4. So positive 4. So all we're doing is finding that m and b value. So b was equal to 4, and m was equal to negative 2 over 5. And so finding those and using those to help us out. For standard form, we're really going to do the same thing. Find my y-intercept. So b value is negative 4, and my slope is 3 over 1. So slope is just going to be 3. Now, in order to get it in standard form, the easiest thing for us to do is really just put it in slope-intercept and change it. So if I have y equals 3x minus 4, then I'm just going to go through my steps to change this. It should be subtracting 3x from both sides. So negative 3x plus y equals negative 4. And then I need to change the sign. So you can think of that as multiplying by negative 1, which gives me positive 3x minus y equals positive 4. So don't need the sign there, but when I'm almost putting a negative, we put a positive there and work it out. So 3x minus y equals 4. That would be our standard form. And so as you work through this, you'll start to notice some patterns that go through for this. When I'm doing my slope here, the number on the end ends up getting multiplied by the denominator. The number in front of the y should be the denominator, and the number in front of the x should be the numerator. And then our sign, if it's a positive slope, we're gonna initially have a negative over here, and so the signs will swap on the last two. So there's some steps that you can notice and kind of use to your advantage when you're changing these around. Some patterns that you'll see, but these the 3 steps that we've done to change it really are our easiest way to work through it. Okay, looking at some more examples. So first it says I have a slope of negative 1/2 and the y-intercept is 6, and it wants us to write an equation in standard form. So knowing that pattern, we'd say, well, if the 1/2 moves over, it'd be positive 1x plus 2y equals should be 12 because we multiply that times 2. But let's do the steps that we would normally do. So y equals negative 1/2 x plus 6. Moving my x value over, changing the sign. So positive 1/2 x plus y equals 6. And then to get rid of the fraction, I'll multiply everything by 2. So 1/2 times 2 is going to be 1x. So x plus 2y equals 12. Okay, so again, that's following those same steps. And let's look at this next example we've got. The slope of 1/3 and passes through the point 4, 2. And writing the equation in slope-intercept form. So what I'm going to do is, starting out, I'm going to write the slope-intercept form and we'll plug in what we know. So it's y equals mx plus b. And we have the slope, so we'll definitely use the slope. And we also have a point here that represents an x and a y value. So what we can actually do is we can just plug in, well, there's a y value of 2 equals the slope, which is 1/3, times x, which is 4, plus b. And so the benefit of this is when I solve this out, it'll solve for b, and I just plug that into my equation. So multiplying this out, I'd have 1/3 times 4, which would be 4/3. So 2 equals 4/3 plus b. So really it's whatever adds to 4/3 to get to 2, but we would either divide by that, so put it in the calculator, divide by 4/3. Or actually, no, we're not dividing, sorry, this is addition, so we're subtracting 4/3. So subtract 4/3 from both sides, and I get 2 minus 4/3, or 6/3 minus 4/3, because 6/3 would equal 2, equals 2/3, which is our b value. So all that's left is I need to plug that in to my y equals mx plus b. So y equals m, which was 1/3, x plus b, which was 2/3. And my signs work out, so we're all good to go there. That is our answer. And if we have time on the video, I will show you slope-intercept option of that as well. Okay, now if our slope is undefined and passes through 2, 4, in slope-intercept form, so undefined is a vertical line, and so this is our Hooy-Vux. So that means a horizontal line is a 0 slope and a y equals. A vertical line is undefined and an x equals line. So we can't really, so writing it in slope-intercept form doesn't really happen because we don't have a y-intercept for this. It's actually just going to be whatever my x value is. So undefined is a vertical line, which means it just all goes through one x value, or x equals 2. On my next one, we have a slope of 4. The x-intercept is negative 16. So all that's doing is giving us where it intersects the x-axis, means x would be negative 16, the y value 0, and so that's just a point that we can use. And in order to do that, we could plug it in like we've done here, or we can use the slope-intercept form, or point-slope form, sorry. This one I'll work out using the point-slope just so we see it. The point-slope is y minus y1 equals mx minus x1. And so we're just going to plug in the y value, which is 0, and the y1 value is 0, x1 is negative 16. So negative 16 would be positive 16, and y minus 0 is just y. So y equals, oh, and my slope is 4. 4 times x plus 16. And so I multiply 4 times x, which would give me 4x. And 4 times 16 should be 64. So, yeah, going from negative 16, should hit that right there. So, that is using our point-slope form. If we had a value in there for y, if y, like y minus 2, we'd add 2 to both sides, and we'd get 66. So, you've also got that as an option when we're working through using this point-slope form. And last but not least, we've got a line that passes through 2 points, doing it in standard form. You can use StatEdit for this, or you've got the option of just finding slope real quick, which would be y2 minus y1 over x2, which is negative 4, minus x1, which is negative 2, so we'll do plus 2, which gives me negative 6 over negative 2, so positive 3. Then what I'm going to do is use one of these points and plug it in, and we'll use the point-slope form just to show that as an example with an actual y value. So that again is y minus y1, which is 5, equals the slope, which was 3, times x minus x1, or x plus 2. So that gives me, and I'm going to write it over here so we can finish out over here, y minus 5 equals, distribute the 3, 3x plus 6, and then we'll add 5 to both sides, so y equals 3x plus 11. So both ways work. If the point-slope form makes sense to you, it can work out a little bit easier there, just depending on what numbers you have in your point. And you could also use the negative 4, negative 1. Should work out the same way. But if you can remember that form easily, definitely use that. If it's trouble remembering different equation, then use the y equals mx plus b, and we just plug in one of the x and y values and solve for b. Both ways work for that. And so that is writing an equation of a line given a lot of different forms.